Hi guys, recently I did a project where I had to create this disco ball here, and initially I thought it would be really straightforward to do this. I mean, just take a primitive UV sphere and instance these tiles on it, but it turned out that it wasn't that simple. So I thought it would be nice to share some techniques I've used along the way to create this disco ball. So when we analyze this disco ball, we see that it is made out of these little tiles which are all evenly spaced. And if we take, for example, a UV sphere, we see that the spacing between the vertices differs at the top and in the middle. So here it is quite far away and here it is really close. So this isn't really useful, and one might think maybe we take an icosphere, because with an icosphere all vertices are evenly spaced. But the problem here is that we don't have these nice horizontal lines which are important for our disco ball. And in my experience, problems like this are very typical when working procedurally. I mean, it's really easy to create really nice abstract effects, but to get simple things like this right can be really hard to do sometimes. So let's start. Let's create a new file and open the Geometry Nodes tab. And here we start by adding a new geometry node tree. We don't need the group input. So first thing I do is I get a curved circle and a line, also a curved line. A mesh line would work too, but I prefer a curved line. Then we take a resample node, and with this I can instance an array of the curved circle. So instance on point. I want this array to go from -1 to +1 in the z-axis. So here I put a -1. And now my idea is to create a sphere out of this. So the first thing we'll do is we'll scale our instances. And a possible way to do this is we take a position, split it up in our separate components. So separate x, y, and z. And we take the z position and put it in a cosine math node. And we use the result for our scale. And now you can see something happens, but it doesn't quite work well. We need it to be 0 at the top. So let's multiply this by half pi. So pi divided by 2. And now it's getting closer. So if we increase our amount, you can see that it is scaled like we wanted, but it still isn't a spherical shape. So the next thing we'll need to do is to offset these circles in the z direction to create this spherical shape. We can do this with a z position node. And we need to access the z coordinate, so combine x, y, z. And again, we take the z position, so I can copy this. A rule of thumb to create circular or spherical shapes is always a combination of cosine and sine. So in this case, I take the sine node, also the z position, and plug it in a z coordinate. And now I again need to multiply this by half pi. And I made a mistake here. I need to put this in the position, not in the offset. And right now you can see I have this evenly spaced circles, which I can use later for instancing our little tiles. So quickly organize this. Then I also create a group input node to control the count of our circles. The next step is to instance our little tiles. So first we create a cube for a tile and an instance on point node. And let's also scale this down a little bit. And here you can see the problem, or you can see multiple problems. First, it is scaled along the z-axis. And to resolve this, let's realize our instances. And the next problem I've talked about earlier is the uneven spacing. So a simple way to solve this would be to resample our curve based on the distance, but you also can do this with the curve to points node. And here I set it to length. And right now you can see the even spacing between our tiles. So right now we are really close, but we have to get the rotation of our instances right. So the first idea would be to put the rotation in here, but you can see it doesn't look that right because our tiles need to be oriented along the normals of a sphere. And a simple way to do this is to take a position node and a vector math node, and here we choose normalize. Basically what this does is it takes our position and creates a vector out of it which points away from the origin of our object in all directions, so it is like a spherical shape, so to say. So right now we can take this rotation and align it to this vector we just created. So align Euler to vector, and then we take this vector here, and here you can see that it nicely looks like we want it to look like. So let's rearrange this again. Also we want another group input node to control the distance between our tiles. And also we create an input for the size of our tiles. So we don't need this to be in vector. We switch this to float. Then adjust this value again. And yeah, we're getting closer. What I don't like about the result so far is that we can see some patterns appear. So it would be nice to randomly rotate each instance circle on its z-axis so it looks more random. So let's have a look here, and we want to rotate each of these circles. So first let's capture an instance of each circle. So capture attribute, switch this to spline and at the top to integer. Then we take an index, and with this index we can use a random value node and put this in the ID input. To describe a complete rotation around 360 degrees in radians, we have to put 2 pi in here. And next step is to take a set position node in combination with a vector rotate node. Then we want to rotate our original position along the z-axis. So we can leave this at the default and put this in the angle input. And right now it should be random. Yeah. So we can create another group input for the seed. Let's put the seed at the top. So the next thing we'll do is we'll randomize the scale of each tile and the rotation. So for the scale we can simply put a random value in here. Then a technique I frequently do is I just put this in the range of -1 and +1. Then I multiply this with a value which we call amount later and add this to our base scale, which in this case is 1, so add. And here you can see with this we can control the random scale. And because we already define our scale here, let's maybe change this. So here we do this, put this to 1 and put our scale in here. And let's also create a new input for the random size. Okay, so next we do the same for our rotation. In this case we simply can add a random vector to our rotation. So take a vector math node, set it to add, and then we take another random value node, set it to vector, and also I put it at -1, and then we take a scale node which is similar to a vector math multiply node. Scale simply works on all axes uniformly, and here I can plug this in, and this is our random rotation amount. So create an input for this. Let's not forget to connect our seed. So right now our disco ball looks nice, but it is hollow. So let's create a solid core. Just simply create a UV sphere and join our two objects. Maybe scale it up a little bit. And also I'd like to shade this smooth. So yeah, and to control the overall scale of our object, let's create another set position node. Take the position, and with a vector math node we can scale it. So set it to scale, and here we can scale it up, and you can see that the size of our instances stays constant. So here we can put in realize instances in between, and right now everything should work as expected. All we have to do now is set up a scene and some materials, and then it's done. So first create two materials, one for the core and one for the tiles. So let's call the first one tiles, create another one, call this core, Then we open our shader editor and see, for the core I switch this to rendered view. The core should be like a dark gray maybe, and we can't see it right now because we have to set it first in our geometry nodes. So here we take two set material nodes. The top is our core and the bottom is our tiles. Switch to our tiles material, and this I'd like to make this metallic. Change the roughness to maybe, yeah, it's a low amount. And right now everything looks really flat. That's because there are no reflections, so I need to create an environment texture. And a simple trick is just to take a noise texture for the background and scale it down. Then we increase the contrast. In my case, I use a color ramp. And you can see these reflections. But still, these reflections are too perfect for my taste. I'd like to randomize it for each tile. And for this, I go into my geometry nodes again. And here I create a random value. Switch this to vector again. It needs to be in a range of 0 and 1. And connect this in my group output, so we can access this in our shader via an attribute. But first we need to define that the value is uniform for every tile. So a way to do this is to take a mesh island node, which creates an index out of each island of connected vertices. And also connect our seed again. Then we go in our output attributes. We name this. Simply name this random. And now we can pull up this attribute in our shader. Just type random in here. And if we look at this, you can see it now is random. And I simply separate this, and I take the R value, which is a simple grayscale value, and put it into our roughness. The next thing we do is we remap this in a lower range. So we need a map range node. And let's say we want to this to go from 0.05 to 0.2 maybe. Yeah, that looks good. And right now the background is a little bit noisy, and I don't like it that way. So let's fix this. A way to do this is to take another color value for our background. Let's say we want it to be really dark. Take a mix RGB node in here and take the light path node. Is camera ray for the factor, and right now only the reflections and the diffuse lighting affects our disco ball, and the background that gets rendered is our bottom value here. So to make everything more shiny, I simply add some lights a nice thing to create this shiny, glowy effect is to simply take a bloom and right now we have this really nice disco ball which is completely procedural. And maybe we should make the scale of the core also accessible via a group input. So yeah, that's it for today. Thank you for watching and see you next time.